And now we're coming to the next session. Next session is headlined with Ethernet transmission under harsh environments. What does that mean? You saw a lot of connectors integrated on a PCB in a device, and the guys were talking about the speed which is able to transmit it, etc., etc. And now we will have Joachim and Stephan on stage again, and they will tell you what are we doing and how are we testing, particular for those PCB connectivity, that those promises are really able to hold on. Thank you, and Joachim, Stephan, welcome on stage.
Yeah, many thanks, Kilian. So we now come to the topic of Ethernet transmission in harsh environments. I have brought with me Dr. Stephan Middelkamp. Maybe you introduce yourself.
Yeah, thanks, Joachim. I'm at HARTING responsible for quality and technologies. Therefore, on the one hand, for the whole quality assurance, quality planning, and the labs. And on the other hand, on the technological side, how do we qualify our products and how do we release them? And this is one of our topics today.
Okay, thank you very much. So on the screen, you see all the PCB connectors HARTING has in our range. So there are a lot of Ethernet-related connectors like M12 decoded, M12 X-coded, RJ45, IX Industrial, single-pair Ethernet. So we really, at HARTING, have a huge range of Ethernet connectivity on the PCB. And referring to the markets which HARTING typically deals with, yeah, those are markets which are really shock and vibration proved, like in the railway business, which is, to my point of view, one of the hardest markets in the world for connectivity. Then we are very present in the robotic market, so also a market where there are a lot of influences from the outside at the robot foot, at the tool, at the flange. So means the IP rating is very, very important. And those robots, they run for more than 25 years, approximately 24 hours a day, 5 days a week. So also here a lot of stress is put on the PCB connectors. Then we have, as another example, the machinery market. So also the machinery market is very special. Here we have, for example, requirements like data transmission, which is becoming more and more important for example, vision camera systems, which we introduced on Tuesday with company SICK. And finally, we also have chemical resistance. So oil and other chemical materials are typically existing in a typical production hall. So also this part is very, very important. And last but not least, for example, in the wind energy market, you can imagine that the climatic requirements are really very, very strong. So means all in all, you can see, referring to the target markets which we deal with, our connectors really need to be very, very well qualified in order to keep the promises my colleagues have done before for the high performance of our connectors. So quality in general is very important at HARTING. So here is the statement of our chairman, Philip HARTING himself. He said that quality, or his grandfather said, quality is when the customer comes back and not the product. And this is something which HARTING really lives and spends a lot of, I would say, even money for over decades, and built up really a high quality system. So if we develop our products, how do we do this? Which very important points do we consider in order to design the products accordingly? So first of all, we have, during the design, a lot of simulation tools, which Stephan will introduce later on. So means even during the design, mold flow, mechanical analysis, and many different other things we test directly during the design. Then the second point is, let me just check. I think the battery is empty. I overtake your one. So second point is product qualification. That's the point where our HARTING Technology Center is very actively with, and which we will introduce later on by Stephan. And the third point is serious production. So no matter how well you have designed your product, how well you have qualified it, at the end of the day, connector business is a high volume mass market, and you need to make sure that even after 100,000 or 2 million pieces produced, the quality is always the same. All right, so let's have a look in our technology center. Stephan.
Thanks. So the core for the release of our products are, of course, the labs. Here we qualify the products and check for the final release and for the robustness of the design. We have one big lab in Middelkamp at headquarters, the HARTING Quality and Technology Centers, and additional labs in China, in the US, in Sibiu, and in India. These allow us to improve the quality already during the design phase and have fast iteration cycles. At the same time, the big lab in HARTING, the leading lab at headquarters, has as well the target of securing the quality of the labs itself, so thereby ensuring that we have the same test standards everywhere and thereby securing the same quality independent on the development location. So let's have a quick look into the lab, where it does come from. So where our labs come from and a brief glance what test possibilities we have for the final release. However, a big disadvantage of a lab test is that you need samples. So each time you have to produce your samples and then test them. So this, on the one hand, you have to create the tools beforehand. On the other hand, the testing takes time. So therefore, simulation is one of the crucial tools we have nowadays as well. So we have 4 different targets for simulation. The first one is more or less just the same like testing. So it's a fast way for validation of the design. So you have the big advantage, you do not need samples, and you can do it based on CAD data, so before you go into tools, and so the modification is much faster. Then this allows you as well as section options that you optimize your design manually by comparison of different designs. So you're not only creating one design, but different one and see which one is better. You can even switch on and off different properties to really see the effects of the design modification. And then, which is at the moment, we have to admit, not state of the art, but we have performed a lot of successful pilots where we use generative design as well. So then you turn it the other way around, that simulation is part of the design. You define your parameters, and the algorithm is optimizing the geometry. Thereby, you get the optimized geometry, a completely different ideas than you do by manual creation of the design. The fourth option is you can perform application-specific system simulations. So because it's an easy way to generate the models and a cheap way to do this, you can as well perform whole system simulation and see how the individual product is performing in the system. Coming to a bit more detail, having a look into 3 different kinds of simulations. The first one is temperature load simulation. So you apply a defined current at a defined temperature, and you see the increase of temperature, and therefore you know how much current you can apply for your different temperatures. This can be done statically, so that you end up in equilibrium. This can be done via ramp up as well, so that you really run up temperature profiles. The second one is a mechanical simulation. You see the stress here on the levers, and depending on the angle of the lever, and of course the geometry. This is a nice example where you can use generative design, because you can then, if you know the allowed stress and the allowed normal force, you can optimize the geometry of the lever itself. Coming to signal integrity, here you can simulate the electromagnetic field of a connector. So here you see the spring of the connector and how the field evolves. This you can then, once again, take as an input and simulate your whole backplane situation. So not only having the connector, but the connection of the connector to the backplanes, also to the different PCBs. And then you get an input signal and an output signal on a different connector in your application. And you see here via the eye diagram how good the performance still is. Due to all this kind of simulations, we still have to do type testing, because at the end, the tests perform a much better visualization of the application. And this is where we want to show that the connector is working in the application. Here we see the different contribution of a type test plan. You start with the initial measurements, which are usually electric measurements, and then you stress the whole connector depending on the application, and measure once again the initial parameters and see whether you have a change in the performance. Stresses could be mechanical stresses like vibration, aging of the connectors, looking onto the base material and the normal force of the connector itself. Can be and are stresses of the surface of the connector. So which kind of surface do you have? You perform mating cycles and corrosion tests on the looking into the surface of the connector. Then aging for long-term behavior like dry heat or higher humidity, ultraviolet or ozone testing, more or less everything you have heard in the other talks. Chemical resistivity depending on the application. And then the whole connection method, which kinds of connection do you have? So do you have an IDC, a crimp, or soldering? There you have to do the different test plans as well. And finally, the Ethernet testing for signal integrity. If you want to see more, we have had a talk yesterday on the lab itself. There we have gone much more into detail, which you will find in the documents as well. Coming to signal integrity, Joachim will give you some insight to this.
Okay, so let's coming to the signal integrity testing. It's a part which is, to my point of view, a very cost intense part with regards to measurement equipment. So in our laboratory here, we have, as a typical example, an HAN module CAT8, which is typically used in in the railway. But we have, for example, measurements of the near-end crosstalk, which you can see here on the screen. Then we have a second one, so it is the testing of the TDR measurement, the impedance profile, which is also very, very important if you qualify a connector here for high frequency. It's a second example of test equipment which we have here in our house. Here, a very nice and precise test fixture. And a third point to mention, for example, is here. What we can see on the screen, it is the transfer impedance by the triaxial method is also a very, very accurate testing, which we all carry out here in our laboratory and can really by this ensure that the quality is always guaranteed. So after qualification, so design qualification, as I mentioned in the beginning, very, very important is that you afterwards really keep the quality in production. Here very important is that you have a high depth of production. So we at HARTING, we are stamping our connectors, we are plating the connectors, so we have many different electrogalvanic plating lines globally, and so we are able to even do different customized contact thickness and so on. And to underline this, so contact thickness and contact quality is not the same, so there is a lot of competence inside. Then we are molding, of course, all our insulation bodies by ourselves. And last but not least, assembly. So assembly of a connector is a very important part. And we do not assemble in-house. We even build most of the assembly machines by ourselves. So we have a tooling department which over decades is building our own assembly tools. All right, so this was the basic outline. I have some videos in the background which just show a typical stamping process and an inline quality control here at the stamping band. We have further quality-related things like a 3D quality check if you would like to measure certain shapes and angles. Yeah, we have here an example of one of our plating lines, which are running here at our headquarters. Also here, quality check is very, very important. So it's more a chemical process here, where we check all the different thicknesses and plating quality, which we are doing onto the connectors. And yeah, last but not least, as I mentioned, so it is the molding and the assembly. All right, so that's how HARTING really ensures the quality of all the connectors which we provide to very harsh markets. And if you have any questions, just contact us by chat or by LinkedIn.
Thank you, guys.
Thank you.
Thank you, Stephan.
Thank you.
Thank you, Joachim. I would like to ask you to stick with me for a second, please. So, Joachim, thank you, Stephan. Because I just counted in the agenda, Joachim, that was your 6th slot on stage here. Yeah. So, contributing content, right? So thank you for that, and this is the reason why I just asked Joachim to stick here with me for the further minute. So 6th slot on stage, but also like a lot of work behind all slots we saw during the 3 days. We are not over yet, but it's your last time here on stage, so thank you for that, and a big virtual applause for you to that. Thank you, and enjoy your lunch.
All right, thanks a lot, and contribution to all the team. Yeah? So it's not just 6 presentations, and even I carried out not one by myself only, so it also was a combination of different colleagues. So thanks to you and to the team.
Perfect. Also, virtual applause, I like it. Yeah.